This week's lecture is going to cover using the Java Database Connection Driver, JDBC, and the second half of the lecture will cover using the repository design pattern with Java in order to provide a way of connecting our software that we write to our persistent storage in the database. So we're going to start by covering what is JDBC. We'll look at getting started with JDBC, how to get it, how to load it, what it is. We'll look at connecting JDBC to a database, and then once we have that connection to a database, we're going to work with it to do the CRUD operations. We're going to look up data with JDBC and get it back. We'll insert and update data with JDBC, and then delete data with JDBC. So to start off with, what is JDBC? JDBC stands for Java Database Connectivity, and it is based on the industry standard database driver called ODBC. There's essentially an ODBC driver out there for almost every language that basically speaks ANSI SQL. And JDBC is the Java implementation of ODBC. The JDBC API is a Java API that can access any kind of table data, especially data stored in relational databases. But it's not limited to relational databases. You can actually use JDBC to connect to flat files like Excel spreadsheets and things like that. It's pretty impressive what it can do. JDBC helps you write Java applications that do three things. They let you connect to your data source and maintain that connection. And that can be challenging sometimes if the connection is over a network, or if it requires authentication, or if it requires multiple simultaneous connections. And JDBC does that pretty well. It'll let us send queries and update statements to the database. So we can read data back from the database. We can update existing records. And then we can also insert new records, delete records, and we can also process the results that we get back from the database in a programmatic, effective manner. So that's what it is, and it serves a very important role in our programming world. To get started with JDBC, you need the Java software development kit. You need a database system. In our example that we'll work with in the second half of the lecture, we're going to use Microsoft SQL Server, and you really shouldn't do this in a production world, but for simplicity's sake, we're just going to use the SA account. The SA account is the SQL administrator account. It's like the administrator account on Windows or the root account on Linux. To that database system, that is the main administrator account. It's always there if you have mixed mode authentication enabled. You should, in a production environment, have an account dedicated just to that one database and for that one application that follows the security principles of least privileged access. But again, for this demonstration, just simply taking the simplest approach. Then we need the JDBC driver for the database management system. And this is a really important thing to consider, the JDBC driver. And that means whatever database system you're using, there will be a different JDBC driver. And the goal with JDBC is you can write one set of SQL commands, and JDBC can translate those into the DBMS language that you need and give you the results back in the same fashion. So if you're using MySQL or Oracle or Microsoft SQL Server, it should effectively allow you to, with very little rewriting, use JDBC for the same queries on the same table structure and get the same data back. You'll need to create the database tables ahead of time and then populate them with data. So JDBC will not manage your schema for you. You can run commands to create your tables, but that's not the normal use case of it. You can create a Java project in Eclipse or BlueJ or whatever developer environment that you want to use. Eclipse is the developer environment I normally use with Java, but the example that we'll use later, we'll actually use BlueJ. You can use any Java IDE, IntelliJ, any of those. And you want to add the JDBC jar file to your project. because this is essentially a third-party library, the one that is specific to your database management system. It's not part of the Java software development kit. So you need to add that third-party jar file to your project and configure the project properties. How you do that will be different for each integrated developer environment. Once you have the library set up, you have your project, you're importing the JDBC objects into your Java project. The first thing that you need to do is to create a connection with the data source that you want to use. And the connection object is going to effectively represent your interface to the database as a whole. And so the data source can be a database management system, it can be a legacy file system. In other words, you can actually connect to a flat file, a CSV file or something like that. You can connect to other data sources as long as there is a JDBC driver available for it. And so effectively the JDBC driver will expose the same public API for retrieving data from that file. Connection is represented by, again, a connection object. Notice capital C, that's the actual name of the object type. Typically, your JDBC application connects to the target data source using either a driver manager or a data source class, one of those two. The driver manager fully implements the class and connects an application to the data source. And that's normally specified in a connection string, what we call a database URL, something that provides information about what host has the database, what the actual database name itself is, how you will authenticate, and a few other things. That connection string can really be tricky to troubleshoot sometimes. The data source is the interface that allows you to get information about the underlying data source itself. So a driver manager will use a data source, but you can use a data source directly. And so that allows you to see information directly about your data source. This is probably more common, I think, if you're using the legacy file system. But depending on JDBC driver that you're using, this may not be public or it may not be fully implemented if the JDBC driver is designed like the Microsoft driver for SQL Server to only really connect to a relational database system. That may or may not be necessary. The driver manager class is the more likely approach that you will use. So connecting to a database management system, use the driver manager class. What you would do is call driver manager get connection and pass the parameters. Now normally the parameters would be your connection string. And so the connection string effectively just again provides all the variables and the values that are needed to talk to a relational database system. And so that gives you your connection to the database. The connection object, the instance you have of the connection object, represents your interface, your API to communicate with the database. So that gives you a database connection, and that requires the database URL, that connection string. And again, that connection string will be different for each database management system. Typically, the database URL specifies the name of an existing database that you want to connect to. So you might say JDBC : and then here's the actual relational database driver. So here's a JDBC MySQL / localhost. In other words, we're going to talk to the MySQL server on our local computer on port 3306. That's the standard MySQL port / MySQL. And that represents database URL for a MySQL database named, wait for it, MySQL. So there's the database name, there's the TCP port number, there's the host number. Now, in this particular example, this would require you to have the MySQL JDBC driver in your project, and it would require you to be hosting a MySQL server instance or MariaDB if you're using one of the compatible forks, since MySQL is open source. This does not have any authentication in this connection string. So chances are with the URL, you're also going to want to pass a username and password to authenticate to that. And so the GET connection would establish a database connection and keep it open as long as you have that connection instance. So here's an example of some sample code. Now this is a little odd to look at. We have a class, JDBC Utilities, and everything here is static. And this means that you don't have to have an instance of JDBC Utilities to get a connection object. There's some things going on here you may have never seen before. So we have a connection object called con. It's not initialized yet, so this is initially a value of null. Create a static string, which is our connection string. Now in this case, this is an example using Microsoft SQL Server. And so we say we have the JDBC driver for SQL Server, also on localhost, and this is just concatenating together these strings. So really this is all, these 3 lines are all the values stored in connection string. You say your database name is sales system, and notice the case. SQL Server at least is very case sensitive. And then we say your username, SA, password, exclamation point. Now the danger with this is, of course, you do have in fact your password as plain text in your source code file. So not necessarily maybe the best way to do it, but it works for development. Now you've probably never seen this before. It's a static, open and close curly braces. For a static method, this effectively acts like the constructor. And so what we say here is static try, and we're going to set connection object instance here, con, is equal to driver manager, get connection with that connection string. So get connection is a static method in the driver manager namespace. We pass it that connection string. That should return an instance of a connection talking to the sales system database on localhost and authenticating with that username and password. So again, in Microsoft SQL Server, you'd have to have mixed mode or SQL authentication enabled. And everything with JDBC lives in the java.sql namespace. And if there are any issues with JDBC, it will throw a SQL exception. So what we do here is we try to get a connection. And as long as the connection string is valid and the SQL Server is running and those username and password work, this will work. But if it fails for any reason, it'll throw a SQL exception. So we'll catch it, set the connection to null, and then print the stack trace. And here we have a static method, get connection, in JDBC Utilities that will return our instance of the connection. And so being static, we initialize the connection in this static constructor. We could just as easily have put this in here, and that might actually make a little more sense to do that. But all right, now database connection URL is a string that your database management system's JDBC driver uses to identify all the variables and their values that it needs to connect to the database and be able to work with it. So if we go back here, we see we've got the host that the SQL Server is running on. We've got the database name of the database on that host that we want to work with. We have a username to authenticate with, and a password to authenticate with. So this alone has 4 variables and their values. So the exact syntax is going to be specific to your database management system. If you're using MySQL, the syntax will be different. If you're using Oracle, the syntax will be different. If you're using Postgres, it'll be different. SQLite, and so on. You get the idea. For Microsoft SQL Server, since that's what the example code I've got will work with, here are 2 URLs that will provide example descriptions of building connection URL. And then they've got several samples of the connection URLs. So here we look at those 2 pages and explain. Here's a link to download the Microsoft JDBC driver. And I want to show you something about this that's very important to know about. They have a zip or a tar.gz because you can run Java on Linux or Mac, and also you can even run SQL Server now on Linux. But here we'll look at the zip file because my Windows system can just open the zip file. Here's the download, and in the folder we're going to see we've got JDBC 8.2.2, that's the version of the JDBC driver. But here it says JRE 8. Then we have JRE 11 and JRE 13. You need to get the correct jar file for your Java runtime environment. So if you're running on Java 8, you need JRE 8. If you're running with Java version 11, you need JRE 11. And likewise, if you're running Java 13. They are not compatible at all. So if you try to put this one in and you're actually running Java runtime 8, it will not work, and vice versa. So just be aware of that. You can put all three of them in, and then in theory it should pick the correct one, but I generally only put the one in that I know that I'm using. So the basic syntax is you have JDBC : SQL Server. This is the Microsoft driver, so you're always going to start with this URL because that indicates it's Microsoft SQL Server. And then they specify the first parameter is the server name, and then alternatively you may have /instance name. The only time I typically run into different instances if you're running SQL Express. SQL Express runs as a different instance on the same server. So you might say localhost or an IP address or a DNS domain name. And then if it's just a standard install, you typically don't have a sub-instance, but SQL Express often runs as an instance called SQL Express. : a port number, that's only necessary if you're running on a non-standard port. I believe the default port for SQL Server is 1433. And then after that, it's a series of name value. You have the property equals value, semicolon. Property equals value, semicolon. And so you pass all the additional properties, all the additional variables this way, name value pairs. And so they explain here one or more option connection properties, and there's a link here to what the various ones are. Here's a very basic example. SQL Server on localhost using the default port numbers as user, my username, : password equals, and then they've given as an example the asterisk to blank out the password. There are a number of other variables that you might want. Integrated security true would be for your Windows authentication. It will just simply use whatever account you're logged into Windows with. Gives some other information there as well. So very, very good description there on the connection URL sample. They've got a number of examples where they show what's going on. They'll give examples and explain what's going on. So the documentation, very, very good to get you started. That's probably the biggest source of frustration getting started, is having the connection string let you connect to your database. Make sure that you can connect using SQL Server Management Studio or the equivalent if you're using a different database management system. And that will tell you that the username password work, that your URL, that the basics in your URL should work. All right, in the basic code we saw earlier, to get a connection object, we did a try catch and we caught a SQL exception. So we're going to go in a little more detail about the SQL exception first. When JDBC encounters any errors when it's interacting with a database, it will throw a SQL exception instead of just a more generic exception. And the Java tutorial on JDBC outlines quite a bit of information about the SQL exception. There's a web link for it right there. The SQL exception has some additional information from the standard exception. It has a description of the error in getMessage. That's part of the exception API. It also has a SQL state code, and that string represents 5 alphanumeric characters, and you can decode that. And so that's a method, getSQLState, and that should be covered in the Oracle documentation. Maybe not on the tutorial, but on the more specific documentation. It'll have an error code as well, and it's an integer value that identifies the error that caused the SQL exception, and you can call getErrorCode to retrieve that value. And then you'll also have a cause. The SQL exception instance might have a causal relationship. In other words, it might be part of a daisy-chained exception. And so that can cause one or more throwable object to throw a SQL exception. So to navigate through that chain, you just simply recursively call getCause until a null value is returned. and that will walk the chain till you get to the original source. Fairly straightforward in terms of exception handling. All right, the next thing that we want to do is work with the data in our database. So once we have a connection object established, then we want to actually work with our database. And so the connection instance is going to maintain the link to the database. So we're going to want to set up that connection instance and keep it active through our application. And then we're going to have three other objects that we work with a lot. We're going to have a statement. A statement object will actually execute some query against the database. So the statement will run from the connection. There's another type of a statement called a prepared statement. A prepared statement is a very important variation of this. It will also execute a query, but it maintains information about the query, like what primary key did the database management system assign to the record. So what this means is a prepared statement, you can run that against the database system to insert a new record. And then the database system will automatically assign a primary key. And after it assigns the primary key, we can get that primary key back without having to run additional queries, and we can know for certain what the primary key is using the prepared statement. So this is extremely important when we are inserting data into the database. And then the result set. The result set holds the return values from the database. So anytime we do a select statement, this is where the data back from the database is going to live in a result set. This works a lot like an iterator in some ways. And so we'll look at some examples of how these work. Now, the connection and the statement objects, these are the most straightforward objects. The connection maintains your link to the database, and so the basic structure of that would be have a connection instance, and it's going to be equal to the driver manager's static method get connection, which takes a connection string. That will return an instance of the connection using that connection string. And that provides the persistent link to the database system itself that JDBC uses to talk to the database, to interact with it. The statement object will execute queries against that database. And so you'll create an instance of a statement this way. You say statement, whatever your instance name is equal to your connection instance create statement. And that statement is then used to execute queries. And what we do in that case is we'll execute query and pass as a parameter a string that holds the SQL we want to actually execute. And that statement will return a result set. So you receive result set rs equals statement execute query with some SQL in the string. It might be as simple as select star from users or something like that. And that will return a result set that includes all of the users. You can also return an integer for the number of rows affected instead of a result set. So if you have like select count users, that can return an integer to say this is how many users there are. Statement can technically execute any SQL code, including inserts, updates, deletes, create table statements, and drop or truncate table statements. So it can run any of those. However, if you run inserts with it, you're not going to get the primary key back. And so that can be a little bit more challenging. So I've switched over to Microsoft SQL Server, and I've connected to localhost with the SA account. And I've gone to a database I created called Provincial. And we see here several tables. And I've gone to the customer table. I right-clicked and said select top 1,000 rows. So this would be my SQL string right here. And when it runs against the localhost database as that user against that database, it returns these records. And so you see here where this is called results, this collection of records. Those results are what are being referenced as a result set. And so essentially a result set is the collection of records that this SQL returns by running this statement. And so again, this SQL statement can run any data definition language or data manipulation language SQL. Now, sometimes though, when we're doing inserts in particular, we need to get some data back from the database system. In particular, we want to know, hey, what primary key did you assign to a given field? And to do that, to let the database management system return that data to us, we need to use a prepared statement. This will execute queries, and it will maintain that information about the query from the database system. So if you have a trigger or some stored procedure that's going to manipulate more than one table, this is also a really good approach. Here in this case, we create an array string called new ID, and it's going to look for the ID field. It's an array of columns that hold the primary key. Now that would assume that that the table you're working with has a primary key of a field called ID. So you'd want to replace this with whatever your primary key would be. Here we create an instance of a prepared statement, and that's going to be a connection prepared statement. But notice here we say we're going to pass it a string called SQL, and then we're also passing it that array of new IDs. And so the SQL will go do the insert statement. In this SQL string would be a series of insert statements, or at least one insert statement. And then we have here prep statement, the prepared statement instance, execute, update. This will actually go run that SQL and tell us how many rows were affected. And then here we say prepared statement, get generated keys, and that returns a result set. And the result set will include the primary key now. And this is a lot like an iterator in Java. You have to call next to get to the first record. And you can keep calling next to move to the next record, the next record, the next record, until next returns null. And so here we see as an example, the result set in this case has only what the IDs are. So to get the ID, we call rs.getInt. All of your result sets have a get, like the scanner. You can get string, get int, get float, get double, and so on. And in this case, we pass it just the number 1. That says give us the first integer in the result set. If you wanted, it's essentially a hash map of name-value pairs. And so if you know the column name, in this case the column most likely would be called ID, you could also say get int and then in quotation marks put ID, and it would get that as a key value pair. The key would be ID, and the value returned would be the integer. You can also do it by position, and that's what this is doing. If you pass number 1, say give me the first position, and so that gives the primary key of the database. We're going to work with this more in the sample code in the second portion of the lecture. Result set will hold the return values for the database, and so result sets are something we're going to work with a lot. Anytime we do a select statement, we're going to be working with a result set to get the data back into our program. So a result set is a collection of rows from the database. Each row can be processed one at a time, like a database cursor. It effectively works a lot like an iterator. And so here we run some SQL on a statement and get back a result set. To move to the first record, we have to call rs.next. And so once it gets to the end, this will throw null. This will return null. So we can use a while loop to iterate over this. So to process each row, we're going to loop over each individual record in the result set. And we can use the result set. This puts it on the first record. So as an example, this would put it on this record. When you call rs.next the first time, it would put it on this record. And what's happening here is we say rs.getInt the column called ID. So it would say, all right, take this column, this row, that value right there, get that value labeled ID as an integer. And we're going to assign that to the field, use the primitive ID value that's an integer. Here we see string first name is result set get string, and we're going to get the string with the column label first name. So over here we'd say first name of that row would be, in this case, Liam. So that would return a string Liam that would be assigned here to first name in Java. And so you would simply do this. You would walk every column of the result set and get the value out of every column in the result set this way and assign it to the Java variable. Now, the sensitivity of your result set is determined by 3 different types of result set. There's a type forward only, which means the result set can move forward, but you can't go back. So the cursor moves forward only from before the first row to after the last row. Again, it's a lot like an iterator. The rows contained in the result set depend on how the underlying database generates the results. This is the default, if I remember correctly. They have a type scroll insensitive. The result can be scrolled. The cursor can move forward and backward relative to where you are, and it can move to an absolute position. So this gives you better control over being able to navigate the collection. And there's a type scroll sensitive, and the scroll sensitive, the results can be scrolled, the cursor can be moved forward and backward, and it can move to an absolute position. And in this case, though, the result set does reflect changes made to the underlying data source while it is open. So the scroll insensitive, we get a snapshot of the database. The scroll sensitive is more like working with a view. The scroll sensitive will always check the underlying database to make sure it's got the most up-to-date record. So while you're working with it, it maintains a live snapshot of the database. The default type is, here we go, forward only. And generally speaking, never had any problem working with that. Not all databases support all result set types. Forward only is the default, and it's the one that everything should use. The other 2 may or may not be available. These are actually easier when you're dealing with a flat file than when you're dealing with an actual database management system. So you're probably really more likely to see these 2 if you're working with a flat file. So the method support result set type will return true if a given result set type is supported, false otherwise. Now the next thing we look at is concurrency. The concurrency of a result set object determines what level of update functionality is supported. There are 2 concurrency levels. You have concurrency read-only and concurrency updatable. Read-only, the result set can be updated. The object cannot be updated using the result set interface. That's the normal use. The updatable, the result set object can be updated using that result set interface. The default is read-only. Not all JDBC drivers support this concurrency, so keep that in mind. Now, to get values from the result set, for the highest degree of compatibility, it's recommended that you treat all result set objects as forward only and as concurrent read only. So essentially, always treat a result set as an iterator where you can start at the beginning and you can go all the way to the end, but once you go past a record, you can't go back. And you should always treat it as a snapshot where you take that snapshot, you look at it, and you assume that it was valid when you went and retrieved the data, but it might not be valid anymore if somebody updated it behind you. So query has a value from the database returned to a result set object. We've talked about that. You loop over each row in the result set by calling the next method on the result set. So there's some examples here on how to retrieve data. So here's an example looking at the coffees table output. We have a statement object, a query, and on the query, they literally just build a string literal of what the SQL command would be. Here we create an instance of our statement by using our connection object, and then we execute that string literal that we built as a parameter on that and return a result set. And then we loop over the result set by calling next. And here they say, all right, our Java coffee name, we're going to pull out of the result set by looking for the column labeled coff_name. So that will get that value as a string. So we look for that column, get its value as a string, and assign it to this Java variable. Here we're going to get an integer, and we look for the supplier ID by looking for a column called sub_ID. We'll read that value as an integer and assign it to this Java object. We're going to get a float by looking for the column called price, get its value, and assign that to the Java price field, and so on. And this is essentially how we interact with the database. We call for each individual field in our class, or each individual piece of data that we need, we're going to call the result set get method and just get the various data types and label the, get the column heading. And after we do this to build effectively one instance of an object, on next we would then build another instance of an object, and so on. And we do that in a try statement in case there's a problem with the connection or anything else. And then we'll catch SQL exceptions in case there's a problem and do some other stuff. But this is the basic structure of all of our JDBC work. Now, sometimes if you have stored procedures that deal with a collection of records, you still can call stored procedures. You can still call SQL functions, but you might need to deal with a cursor. And so as we talked about previously, you access data in a result set through a cursor, which points to one row in a result set at a time. Remember, stored procedures can work with one record at a time. When a result set is first created, the cursor is positioned before the first row, just like we talked about with the iterator and so on. You can move the cursor by calling result set next. There are other methods available to move the cursor around, but next is what we typically use because it works with the forward only. So next is the most common. If you're using forward only, this will not be available, but the other two that support concurrency, you could call previous. If you have concurrency support, you call first to move to the first line, last to move to the last line. Before first moves you to the beginning of the result set, just as though it had just been retrieved. After last takes you to the end of the result set where you would get out of a while loop and so on. Relative and number of rows would be like move forward 5 rows, move backward 3 rows from wherever your current position is. And absolute, a row, position the cursor on the row specified by the parameter, whatever. So it'd say, go to the third record in this result set would be the absolute. But typically we're going to use next. Now, to get an individual column value out of a row, in that case, we just saw the example. There are two approaches. You can retrieve values using either the index number of the column. So what this would do, if I go back to the SQL Server, if I say, give me column 1, that would give me this column. I'd say, give me column 2, that would give me this column, 3, and so on. It does not use a 0-based index. It used a 1-based index. Columns are numbered, columns are numbered from 1, not 0. You can also, though, use the alias or the name of the column. So I could say, double quote, ID, double quote, and it would give me this column. What's nice about the double quote method, it uses a hash map under the hood, a series of key value pairs. The column order does not matter when you use that. And so that's generally my preferred method, because if the columns come back in a different order than what I expect, the name of the column will still always get what I need. But here are some examples in this tutorial as well. Now, to integrate JDBC with Java objects, this is an older set of slides. I've updated my application quite a bit. We're going to get into this in the next lecture. So I do have a JDBC example project that I'll show in the next lecture. We're going to work with a different database and a different object. All right, so we've talked about what is JDBC. I think I've given you enough here at this point to get you started with JDBC without the examples that I'm going to cover in the next lecture, but still, it's good to have them available as well. We're going to cover the repository design pattern also in the next lecture. We talked about how to get a connection to the JDBC database through the connection object. You want to maintain that instance so that you can, throughout your application's life cycle, so you can always work with your permanent data store, your persistent data store. We talked about looking up data with JDBC by executing a statement and getting a result set back. We also talked about inserting and updating data. JDBC, you can use a statement or a prepared statement to do that. The only real time you probably want to use a prepared statement is if you're inserting, typically. And then we didn't really talk about it, but with a statement, because you can run any SQL, you can also delete data with JDBC, because effectively you're just passing a string that represents your SQL code. So JDBC is very, very powerful, very capable. It is a prime way of dealing with persistent data in an application. Beyond JDBC, I would encourage you to look at Hibernate. Hibernate is sort of the next level up from JDBC. And Hibernate is a true object relation mapping package. JDBC will get you everything you need. In fact, Hibernate uses JDBC under the hood. But having said that, though, still, Hibernate would be the next level beyond this. So I would encourage you to look at that at some point in time. If you have questions, please get a hold of me, let me know.